Hi, today we're gonna check if your transaction is present in the blockchain or not. So, what happens whenever a new block is added to any blockchain? Suppose, like in B2, it will consist of n numbers of transactions. That n, okay, suppose it can be 8, 16,000 or some, you know n times. Now in that n transaction hash, how you will find whether your transaction hash is there or not? To solve this problem, we use Merkel tree. So what is a Merkel tree? Merkel tree is basically a layers of node, and uh, so what happen is that hash of all these transactions will not be added to B2, but there will be a total Merkle tree submission of hash will be added to B2. I'll show you an example of a Merkle tree. So this is how a Merkle tree looks. It has layers. Each layer will have nodes power 2 2 power n. 2 power n means either it can be 2, 4, 8, 16, 32, 64. It cannot have like 3, 5, 6, 7. Why is that? Because we are adding two nodes together to make the next layer. Suppose if we have only 6 node here, so it will make only 3. Then we don't have anything else to add here. We can duplicate this one and then again add it. Then it's same thing like adding h5 and h6 again in the layer 0. That's why we should always use 2 ki power n for creating of a Merkle tree. So in this I have taken 8 transactions. Suppose my block is adding 8 transaction and I want to check whether my transaction is 3. I want to check whether transaction 3 hash is there in the root or not. So how it will be checked? So hash 1 plus hash 2 will create hash 1 2 in layer 1. Hash 3 hash 4 will create hash 3 4. Hash 5 h6 will create h5 6. h7 and h8 will create h7 8. Okay, again this 2 will add and create h1. These two will add, create h2. These two will add and create h1. So this is how Merkle tree works. Now there is two way to calculate this root hash, the main hash. First is you can take all the transaction hash of the block, add it, create your own Merkle tree and check whether your root hash matches with the actual root hash. If it is, then your transaction is there. But it's a very tedious process. First of all, you need to have all the 10 transactions hash. Okay, then you again need to do complex computation to make a Merkle tree. So if you really want to, there is a simple way also to find the main hash root. In that we will need only 4 hash of the node. First hash will be your element hash, which will be the transaction element you want to check. Second will be the proof element, which is next to it. Okay, so if we have both of them, we can add and get h34. We will need the transaction for h12 and h2. So adding these will give us h34. We already have h12. We will add both of these, then we will get h1. We have h2, we will add these and we will get h1 root. So using this we will need only 4 hash, h3, h4, h12 and h2 to get to the root hash. So this is how we check whether a transaction is there or not. In next video, I'll show you a demo how you can do it in the Solidity and check whether your transaction is there or not.